Alright guys, so I'm going to go through this osmosis activity with you. I'm not going to do all of them, but I'm going to walk you through how to do it. So be patient with me because I'm doing this on an old an old iPad, so it's not going to be the most friendly. Alright, so with osmosis is basically how water moves in and out of a cell, okay? So each one of these beakers we're imagining that a single animal cell has been placed into that beaker, and every single beaker has a different solution. So what a solution is it's going to be water and solute. So like we can say like salt or sugar. So the first thing we're going to do is you have to look to see if you can fill in any missing percentages. So this first one right here doesn't have any missing. The second one doesn't have any missing things. No missing. But right here, you can see that there is a missing percentage. So everything inside of the cell should equal 100%. Everything outside of the cell should equal 100%. So you'll do 100 minus 25. So we will have 75% H2O. Then right here, it'd be 90 to make 100. To have 50. Okay, so you'll do that for both pages, okay? So number 2 says draw an arrow to show which way the water would move by osmosis. So water moves from where there is more of it to where there is less of it. It's just like you're in a crowded room and everyone's shoved in the corner. You're going to try to move to a spot where everybody else isn't. So you're going to try to like evenly distribute the water. So if there's more water here, we have 90 here and 85 here, then the water is going to move out because, that's a terrible arrow. It's going to move out because 90 is more than 85 and it wants to get away from where there's more of it. Okay, so it says predict the effect of water movement on the cell. Is the cell going to shrink, expand, or stay the same? Well, if water is leaving the cell, that means it's going to get smaller. It's going to shrink. So I'm going to write that right here. Oh my goodness, I need a pen. So it shrinks. It's just like you're letting air out of a balloon. So if you're leaving air out, it's going to get smaller. And then it says identify the type of solution in which the cell is floating. Hypertonic, hypotonic, and isotonic. So this is the thing that is actually new to you, okay? So we are looking, it says identify the type of solution. So now we're going to look at just the solution. So this solution, we're going to look at the solute part. Okay, so it has 15% solute here and 10% here. So that means that there is more here. So if there is more solute or salt or sugar in the solution than there is inside of the cell, that makes it hypertonic because that means there's more. Just like a person who is considered hyper has more energy than a normal person, a hypertonic solution has more solute. So I'm going to erase this. All right, let's do the next one. All right, so there's no missing percentages. So we're going to draw an arrow to show which way the water would move. So we have 40% here. We have 90% here. So it's moving in the cell because it's trying to get away from the 90 and into the 40. So predict the effect of water movement on the cell. Is it going to shrink, expand, or stay the same? It's going to expand because it's like you're putting more water into a balloon. Man, that looks awful. All right, solution type. So now we're looking at the solute. All right, so the solution, this right here, has less than inside the cell. So it's hypo. Means it's going to get smaller. So something to help you remember hyper and hypo is hypo solutions. When the water goes in, it's a hypo solution. Okay? Hypo, like hippo, it's going to get big. And then hyper, it's going to leave the cell. It's going to get smaller. All right. So now let's look at, so we have a hyper solution here, a hypo solution here, and now let's look at this one right here. This is a iso. So it's even, so the water is going to go in and out. It's going to stay the same. That looks terrible. And the solution type is isotonic because it's even. And then we're done.